So we'll start with the physics paper discussion. The first question says, consider a water tank shown in the figure. It has one wall at x is equal to L and can be taken to a very wide in the direction Z. When filled with a liquid of surface tension S and density rho, the liquid surface makes an angle theta naught, where theta naught is very, very smaller than 1, with the x-axis at x is equal to L. If y of x is the height of the surface, then what is the equation for y of x is the question. So here, as shown in the diagram, you can see here, okay, so this is the curvature formed here. At a point A, if you see here, at a particular point A here, okay, if you try drawing a slope, the value of slope will be very much smaller here. Okay, the value of slope would turn out to be very much smaller. Okay, so what is the actual equation which relates the pressure difference with respect to radius of curvature is pressure difference is given by S surface tension divided by the radius of curvature. Okay, let me say this particular distance over here to be y. Okay, to be y over here. So we have r is equal to 1 plus dy by dx whole square to the power 3 by 2 whole divided by d square y by dx square. Okay, so in this particular case, clearly from the diagram, it is evident that the value of dy by dx is almost equal to 0, or I can say it is very small. So from here, I can obtain r is equal to 1 divided by d square y by dx square. Substituting the value of r in this particular equation, I would be getting delta P is equal to S d square y by dx square. So pressure difference, right? Pressure difference is nothing but the rho g into the height column, rho g y, right? From here, it can be also written as d square y by dx square is equal to rho g y divided by s. So here in the option, we are having it in the second option over here. Moving on to the next question. A microscope has an objective of focal length 2 centimeter, eyepiece of a focal length 4 centimeter, and the tube length of 40 centimeter. If the distance of distinct vision of the eye is 25 centimeter, the magnification in the microscope is going to be. Okay, so we are talking about the compound microscope over here. So for the case of compound microscope, we have the data have been given. The formula for the magnification is given by m is equal to L divided by F naught into D by Fe. Now, what are the parameters given here? Focal length of the objective length is given as 2 centimeter, and focal length of eyepiece is given as 4 centimeter. The distance of distinct vision, capital D value is 25 centimeter, and the length which is given over here, the length of the microscope, the tube length is mentioned as 40 centimeter. So just by substituting all these values, we would be getting the magnification of the microscope. So m is equal to 40 divided by 2 into 25 whole divided by 4. So you are having the option here, magnification to be equal to 125. Again, option 2. So the next question here. An electron of mass 9 into 10 to the power minus 31 kg and charge 1.6 into 10 to the power minus 19, moving with speed c by 100, okay, is injected into a magnetic field of magnitude 9 into 10 to the power minus 4 Tesla, perpendicular to its direction of motion. We wish to apply a uniform electric field together with the magnetic field so that the electron does not deflect. So the electron does not deflect from its path. Then we are asking what should be the value of the electric field and how it should be having its direction with respect to the magnetic field. Okay. So let me just take down the given data first. The mass is given as 9 into 10 to the power minus 31. Okay. And the magnitude of the magnetic field, which is given over here. Okay. This is equal to 9 into 10 to the power minus 4 Tesla. Okay. Now, in which case we will be having, the condition is the electron should not get deflected from its path. Okay. The electron should not get deflected from its path. Now, when electric field also should be not equal to 0 and magnetic field also should not be equal to 0, and the particle also should not undergo any sort of deflection. So, this particular case which is there, when E naught E is not equal to 0 and B is not equal to 0, okay, in which condition the particle will not have any deflection? If the magnetic force value is exactly equal to the electrostatic force given here. If this condition is satisfied, okay, provided that magnetic field is also perpendicular to the electric field, we can say the particle won't undergo any sort of deflection. This is what we are calling it as the velocity selector condition, right? So when Q gets cancelled, you will be having here the value of E to be equal to V into B. And what is the velocity value they have given here? The velocity of the speed of the particle is c by 100. Okay, so I can say this as c by 100 into 9 into 10 to the power minus 4. This is equal to 3 into 10 to the power 8 divided by 100 into 9 into 10 to the power minus 4. Okay. So this is the thing. Okay. So on simplification, I would be getting the value of E to be equal to 27 into 10 to the power 2. So also, what should be the direction? What should be the direction in this particular case? The direction should be perpendicular and the magnitude value is mentioned here. So this is also option 2. There are two inclined surfaces of equal length L and same angle of inclination 45 degree with horizontal. One of them is rough and the other one is perfectly smooth. A given body takes 2 times as much time to slide down on the rough surface than on the smooth surface. The coefficient of kinetic friction between the object and the rough surface is closer to. This is the condition. Okay, so here they have taken two inclined plane okay, one is given as smooth and the other one is rough. Okay, the other one is rough. Okay, this is the condition. So on both the cases, the length is same and a object is kept. Okay, so whatever the time is taken for, in case of the smooth surface for the body to slide down, twice of that time is taken by the case in when the body is placed in the rough inclined plane. So here, when an object is kept here, we would be having in this direction mg sine theta component. And similarly, here also we will be having mg sine theta. Along with that, the friction is also going to be there. Now, when I'm talking about the acceleration part, acceleration on a smooth surface, let me give it by g sine theta. Okay. And here in the rough surface, the acceleration value would turn out to be g sine theta minus mu k g cos theta. This mu k over here is the coefficient of kinetic friction. Okay. And the thing which is same for both the cases is they both transverse the same length. They both transverse the same length. Okay. So I can directly apply or go for the second kinematic equation. I can say L is equal to half AS TS square. Okay. This will be equal to half AR TR square, where AR is the acceleration of the body in the rough surface and TR is the time taken for the body in the rough surface to slide down. According to the given condition, the value of TR should be equal to twice of TS. Twice of TS. Okay. So here we can just substitute for a result. So I can write G sine theta is equal to G sine theta minus mu k G cos theta. The 4 which is over here, I'm taking here and dividing it by 4. Or from here, I can write mu k cos theta is equal to mu k cos theta is equal to sine theta minus sine theta by 4. This can be written as 3 by 4 sine theta, or I get mu k is equal to 3 by 4 tan theta. Tan 45 value is 1, so the value of mu k is equal to 3 by 4, or according to the option, I can say it is 0.75. The kinetic energy of two similar cars, A and B, are 100 joule and 225 joules respectively. On applying brake, car A stops after 1000 meter and car B stops after 1500 meter. If FA and FB are the forces applied by the brakes on the car A and B respectively, find the ratio of FA by FB. Okay. So this is the concept. There are 2-3 more ways in which you can solve this particular problem. We can either go for the work energy theorem, or we can also apply the concept of stopping potential, right? So now according to the work energy theorem, the total work done is given by the change in kinetic energy. According to the question, and you read itself, it's very evident that the body is coming to rest condition at the final state, right? So our final kinetic energy is going to become 0. So whatever the change in kinetic energy is there, that will be exactly equal to the initial kinetic energy value when we talk in terms of the magnitude. When we talk in terms of magnitude, now what is happening? The kinetic energy which is there, this will be equal to work, right? Force into S1. Kinetic energy 1 will be equal to force A into S1. Kinetic energy 2 will be equal to force B into S2. All we can do is take the division, take the ratio of both the values. Okay. So from here, what is the first kinetic energy value given over here? It's 100 divided by 225. This will be equal to FA divided by FB. And what is the stopping distance mentioned over here? 1000 divided by 1500. From here, I would be obtaining FA by FB is equal to 1500 divided by 2250. 2250. Okay. So this is getting equated to 2 by 3, which is our final answer. Okay. The current passing through the battery in the given circuit is. So to find what is the current passing through the battery, my first target is to find the equivalent resistance in this particular case. How would you find the equivalent resistance? Okay, we can do the nodal point analysis over here. So if you see here, okay, so this particular configuration which is there, it is somewhat looking similar to that of a Wheatstone bridge configuration. Okay, so here you see 3 and 5 which is there, 3 by 5. This can be equated to 1.5 divided by 2.5. If you can see here, the ratios on the arms of this particular branch are getting equated. This is nothing but the balanced Wheatstone bridge condition. This is the balanced Wheatstone bridge condition. Now, when the Wheatstone bridge is in the balanced condition, I can say the potential at point A and the potential at point D is going to be same. So in that particular case, our 6 ohm resistor which is there, this gets short circuited. So now we can simplify this particular circuit here afterwards once we neglect the 6 ohm. So once if you neglect this particular 6 ohm, you can see that 5 ohm and 3 ohm, they are in the series combination, and 2.5 ohm and 1.5 ohm, they are also in the series combination. So how you can draw a simplified circuit for this? This can be redrawn this way. 1.5 5.5 ohm, here 1 by 3 ohm, 5 volt, and you're having 1.5 ohm here. This becomes 8 ohm, and here we would be getting 4 ohms. 2.5 plus 1.5, 4 ohm. Okay, now if you see what is happening, these two resistors which are there, these two are in parallel combination. So these two are in parallel combination. What will be this equivalent? 8 into 4 divided by 8 plus 4, 12. So redraw this particular circuit again. Here we can assume as if we have 8 by 3, 1.5, 1 by 3 ohm. Here the battery is there, and we have here 5.5. Okay, what you have to do is take the addition of all of these. The R equivalent value over here will be equal to 8 by 3 plus 1 by 3 plus 1.5 plus 5.5. This is equal to 10 you would be getting. So the R equivalent, the net resistance in the circuit you have obtained as 10 ohm. Now current through the circuit V is equal to I R equivalent, or I can say I is equal to V by R equivalent. What is the value of V? 5 divided by 10. This will be giving you 1 by 2 ampere, or what we can say is as 0.5 ampere. Moving on to the next question. A bob of heavy mass M is suspended by a light string of length L. The bob is given a horizontal velocity V naught as shown in the figure. If the string gets slackened at the point P, when I'm saying the string is getting slackened, that indicates that the tension becomes 0 over there, making an angle theta from the horizontal. the ratio of the velocity v at the point P and the initial velocity v naught. Okay, so this particular question is a concept of vertical circular motion. It's a concept of vertical circular motion. What you have to understand is it is an application of conservation of energy again. Okay, so let me say this particular point as A and this point as B. Take it this way. So my total energy at point A should be equal to total energy at point P. Let me say this way. Okay, so this particular distance which is there, it has given as L, which is acting like the radius of my vertical circle. Now what I have to do, I have to find this particular height as well, because if I'm considering this to be my reference level, from this particular reference level I must be having an idea what height the point P is located at. So for that I need this particular height. Let me call this as H. And obviously no, since the radius is L, this particular length also should be L. So this is something looking like a right angle triangle. From this relation, I can say H can be written as L sine theta. L sine theta. Okay. Now at point P, what is the energy? It is half m v naught square. This will be equal to, so at point P, even though the string is getting slackened, what happens? Some velocity will be there. So according to that velocity, we will be having one kinetic energy component plus mg into, what is the height from point A? L plus h. From here, I can say half mv naught square is equal to half mv square plus, what is the value of h given over there? L sine theta. Substituting the value, I can write mgl into 1 plus sine theta. 1 plus sine theta. Okay. Also at this particular point, when the body is going to be there, okay, some centripetal component is going to be there. Until and unless there is a centripetal component, you won't be having a complete circular motion at all possible, right? So with respect to that, I can say the, if I'm saying that the velocity or the weight component which is there here, so weight will be mg downward along the particular length or towards the center. I will be having, if this is theta, I can say I'll be having here mg sine theta component if you resolve. So from here I can say my mg sine theta will be equal to m v square by L, the centripetal force. Mg sine theta is the component of weight which is contributing to my centripetal force. Okay, from here I can conclude V is equal to GL sine theta root over. Now here what happens? From here I can say, if I'm cancelling out m by 2, m, here 1, 2 will get added up. Okay. So let me substitute it later on in the next step. This gives me V naught square is equal to V square plus 2GL into 1 plus sine theta. Just now we have obtained an expression for V square, right? You can substitute it here. V naught square will be equal to, GL sine theta plus 2GL plus 2GL sine theta. Or I can say V naught square is equal to 3GL sine theta plus 2GL plus 2GL. Okay, they are asking you the ratio. If I'm saying V naught, just if you are taking the V naught, what happens? You will get the root over part. Okay, so from here I can write V by V naught is equal to GL sine theta whole divided by, here GL you can commonly take outside, GL into 3 sine theta plus 2 root over. This will be equal to sine theta by 3 sine theta plus 2 whole to the power 1 by 2. This is the option we are having here. Option 4. The output Y of a given logic implementation is similar to that of the output of which gate is the question. So first, identification of the logic gate is important. Okay, here this is a NOR gate. I can say the two inputs given to this gate are A plus B. This is OR gate. Bar indicates it's a NOR gate. Okay, again here this is a NAND gate. Here also A dot B input is A and B. A dot B bar. This is the NAND gate. So this NOR gate and the NAND gate outputs are again given to one particular AND gate over here. So I can say the output here is A plus B whole bar into A dot B bar. Now we have to analyze what is going to be this particular function. Okay, so A plus B whole bar into A dot B bar, right? This particular expression can be written as A plus B plus AB whole bar, just the Boolean algebra expression. So from here I can also write A plus B into 1 plus A. 1 plus anything will be equal to 1 bar. This can be written as A plus B whole bar. This is actually behaving like a NOR gate. So if in case you are having any particular confusion with respect to this particular Boolean algebra configuration and De Morgan's law application, you can quickly draw a truth table and get the answer. You can verify the input with respect to the output. So it is going to give you the same truth table which corresponds to a NOR gate. The electric field in a plane electromagnetic wave is given by the equation. Okay, from the equation itself, it is very clear that the electric field is in along z direction. The electric field is along the z axis is equal to 60 cos of 5x plus 1 plus 5 into 10 to the power 90. X and t both are having same signs. I can say the electric field is along the minus z direction and the wave propagation is happening in the x direction. The wave propagation is occurring along the x direction. Okay, the expression for the corresponding magnetic field is, now we know that according to the properties of electromagnetic waves, the wave propagation, electric field and the magnetic field, all three are mutually perpendicular. So if in case electric field is along the z direction, wave propagation is happening along the x direction, definitely the magnetic field vector should be along y axis only. And also we know electric field and magnetic field, they don't have any phase difference. So whatever this particular data is there, it will get retained. All we have to do is find the amplitude of the magnetic field vector, B naught value. How would you find the value of B naught? E naught by B naught is equal to C. From here I can write B naught is equal to E naught by C. What is the value of E naught over here? 60 divided by 3 into 10 to the power 8. You can get here B naught is equal to 20 into 10 to the power minus 8, or can be written as 2 into 10 to the power minus 7. So substituting this value in this particular equation, I get my answer as a ball of mass 0.5 kg is dropped from a height of 40 meters. The ball hits the ground and rises to a height 10 meters. Impulse imparted to the ball during its collision with the ground is. Okay. So what is happening? Impulse is nothing but the change in momentum we have to calculate at that particular instant. So if this is the ground, the ball is falling from a 40 meter. After hitting, it is again raising back to a height of 10 meter. Let me say it hits the ground with a velocity vi. After hitting back, when it is bouncing back with the velocity Vf. Vi will be equal to Vf only if it is a elastic collision. So clearly when they are saying it is not reaching the same height, it is not elastic collision. That is my conclusion here. Okay. So impulse imparted, impulse delta P is given by m into Vf minus Vi. What will be the value of Vf? Vf will be given by 2gh, 2 into 10 into 10 root over, I get 10 root 2. Vi will be given by, since it is downward, I can say minus root over of 2 into 10 into 40. 2 into 10 into 40, or I can say Vi is equal to minus 20 root 2. So the impulse delta P which is there, the mass is 0.5, or I can take it as 1 by 2. 1 by 2 into the final velocity 10, minus of minus becomes 10 root 2 plus 20 root 2. Okay, this is equal to 30 by 2 root 2. This is equal to 15 root 2. 15 root 2 is not there in the option, so you have to put the value for root 2. So 15 into 1.4. Okay, it will be nearly equal to 21. Question number 11. AB is a part of electrical circuit. The potential difference VA minus VB at the instant when current I is equal to 2 ampere and is increasing at the rate of 1 ampere per second. Okay, so here we are having one inductor, battery and a resistor. Okay, so here what will happen? The potential drop along the inductor epsilon can be written as L di by dt. What is the value of L here? 1 into rate of change of current is 1. So from here I can say epsilon is equal to 1 volt across the, for inductor case. Okay, start applying the Kirchhoff rule. Start from point A. VA, voltage drop is occurring minus 1. You're going opposite to the direction or sign convention of the battery. So again minus 5. Potential drop will occur across the resistor. So minus potential drop across the resistor is V into V is equal to IR. I value they have given it as 2. So 2 into 2, this will be equal to VP. Or I can say VA minus VB is equal to 2 plus 5 plus 1. This is equal to 10 volt. A 2 ampere current is flowing through two different small circular copper coils having the radius ratio 1:2. The ratio of their respective magnetic moments will be, the ratio of their respective magnetic moment is going to be. Okay, so we know the magnetic moment formula M is equal to current into area. Current into area. Now area again it is equal to pi radius square. So I can say moment of inertia is directly proportional to radius square. Okay, so what happens? Moment of magnetic moment which is there, it will be equal to, the ratio will be equal to the ratio of the radius square. So this will be equal to 1 by 2 whole square, or I can say 1 by 4. In a certain camera, a combination of 4 similar thin convex lenses are arranged axially in contact. Then the power of the combination and the total magnification in comparison to the power P and the magnification M for each lens will be. Okay, so this is the question which they are asking you. Okay, so what we have to do is we have to apply the concept of effective focal length and power. Okay, effective focal length and power. Okay, we very well know the power value is obtained from the reciprocal of the focal length. The power value is obtained from the reciprocal of the focal length. I can say 1 by F effective is equal to 1 by F1 plus 1 by F2 plus 1 by F3 plus 1 by F4, since here 4 convex lenses are being used. 4 convex lenses are being used. Now, when you take the reciprocal of these 4 convex lenses, what I can say is I will be obtaining the effective power P1 plus P2 plus P3 plus P4. In the question, they have clearly mentioned that all the lenses are similar. If all the lenses are similar, what they are indicating is they might be having same focal length, and if same focal length is there, the power value is also going to be same. So I can say my effective power is equal to 4P. So obviously these two are not, option 2 and option 4 gets eliminated. The next thing what they're asking is the effective magnification of the arrangement. The effective magnification can be obtained from m into m into m into m is equal to m to the power 4. So the correct answer is option 3. An oxygen cylinder of volume 30 liter has 18.20 moles of oxygen. After some oxygen is withdrawn from the cylinder, its gauge pressure drops to 11 atmospheric pressure at 27 degrees Celsius. The mass of the oxygen withdrawn from the cylinder is nearly equal to. Okay. How much mass of the oxygen has been withdrawn is the question they are asking you here. Okay. So how much 30 liters are there? Okay, 30 liters of oxygen is initially present at 12 atmospheric pressure. Okay, so this is the given condition. Okay, so now here we know the formula PV is equal to nRT. PV is equal to nRT. Okay, so here the absolute pressure which we can take here. Okay, the absolute pressure according to the given condition, it will be equal to 12 atm. Okay, 12 atm. This has to be converted into the standard value. 1 atm is given. Okay, so from here I can write 12 into 1.01 into 10 to the power 5 pressure into volume. 30 into 10 to the power minus 3 meter cube conversion will be equal to n into R value is 100 by 12 nR T. 27 degrees Celsius means 300 Kelvin. On simplification of this particular equation, you will be getting the value of n to be equal to 14.544, roughly equal to 14.544. Now already what is there? Now already what they have given is, they have given the moles, the number of moles which was already present is given as 18.20. Okay, now initial mole value is equal to 18.2. The final value will be equal to 14.54. How much removal has occurred? Removed value will be equal to the difference between these two. It comes around 3.656 moles. 3.656 moles. Okay, 3.656 moles. Okay, now in this particular condition, 1 mole will be corresponding to 32 gram. For this much mole, the value in kg we have to find. That's it. Okay. So I can say 3.656 mole corresponds to 32 into 3.656. This value will give you out in the grams. We need in kg, so divided by 1000. Divided by 1000. The value will be nearly equal to 0.116 kg. The next question. In some appropriate units, time t and position x, relation of moving particles is given by t is equal to x square plus x. The acceleration of the particle is, okay, the acceleration of the particle is. Now here they have given the relation between the position and the time. Double differentiation of x with respect to t gives us the acceleration value. That's what we have to do. Okay. So the value here is t is equal to x square plus x. So I can say 1 is equal to 2x into dx by dt plus dx by dt. I can say 1 is equal to 2x plus 1 into dx by dt, or I can say dx by dt is equal to 1 divided by 2x plus 1. Differentiate this once again to obtain acceleration. D square x by dt square will be equal to minus 1 divided by 2x plus 1 2x plus 1 whole to the power 2x plus 1 whole to the power 2. Again applying chain rule, differentiation of 2x will give you 2 over here. Okay, this is the value of d square x by dt square. This is the value of the velocity. Okay, this is the value of the velocity, or what else can be done is acceleration which is there. Okay, acceleration which is there. Again, instead of applying differentiating with respect to time t and applying again one more dx by dt, what we can do? V dv by dx. So differentiate this once again, you will be getting dv by dx is equal to minus 2 whole divided by 2x plus 1 whole square. Substitute both the values here. From here I will be getting a is equal to, what is the value of b? 1 by 2x plus 1 into dv by dx will be minus 2 whole divided by 2x plus 1 whole square. So from here I can get minus 2 whole divided by 2x plus 1 whole square to be the whole cube. This will be my answer. An alternating current chapter problem. To an AC power supply of 220 volt at 50 hertz, a resistor of 20 ohm, a capacitor of reactance 25 ohm, and an inductor of reactance 45 ohm are connected in series. The corresponding current in the circuit and the phase angle between the current and the voltage is respectively. At first, what we have to do is we have to find the current value. To find the current value, we have to find what is the total opposition to the current. That is nothing but the impedance value. Okay. What are the data given here in the question? The resistor value is given as 20 ohm. Okay. Inductor capacitive reactance XC is given by 25 ohm and inductive reactance is given as 45 ohm. The impedance value which is there, R square plus XL minus XC whole square root over. From here I get 20 square plus 45 minus 25 whole square root over. We can get this as 20 square plus 20 square root over. This is equal to 20 root 2. Now, the voltage value which is given. What is the voltage value? 220 volt. 220 volt. Okay. The current which is there can be obtained by the voltage divided by the impedance is equal to 220 volt divided by 20 root 2. This is equal to 11 by root 2. Okay. 11 by root 2. So 11 by root 2 is not there. How else you can obtain 11 by root 2? You can say this as 11 by 2 root 2 for the easier simplification, or 5.5 into 1.4, or I can get current is equal to 7.8 nearly. 7.8 nearly. Definitely it is not something near to 15.6. So either of this option is the correct one. Now what we have to do, we have to find the phase angle. So for finding the phase angle, I can write cos phi is equal to R by Z. R value is given as 20, Z value is 20 root 2. So I can say cos phi is equal to 1 by root 2, or from here phi value is equal to 45 degrees. So my answer is option 2. The sun rotates around its center once in 27 days. What will be the period of revolution if the sun were to expand to twice its present radius without any external influence? Without any external influence, this word you have to notice. Without any external influence means they are actually talking about conservation of angular momentum. Okay. So according to conservation of angular momentum, I can write I1 omega 1 is equal to I2 omega 2, or I can write I1 2 pi by T1 is equal to I2 2 pi by T2, or I can write I1 by T1 is equal to I2 by T2. What is this I here in case of angular momentum? It is nothing but the moment of inertia. So sun which is there, let me take it as a case of sphere. So I can say 2 by 5 m r square whole divided by, what is the time taken? Given the question is asked, the data is given in days, and also in the options it has been mentioned in terms of days, so you don't have to do any sort of conversion. So time period is 27. This will be equal to what they are saying. The radius is expanded to twice, which means here what happens? The moment of inertia 2 by 5 m into 2r whole square divided by T2. So here 2 by 5 m, 2 by 5 m goes off, r square will go off. From here you will be having 1 by 27 is equal to 2 square, 4 by T2, or I can say T2 is equal to 27 into 4. So the answer will be 108 days. A model of quantized motion of an electron in a uniform magnetic field B states that the flux passing through the orbit of an electron is n into h by E, where n is an integer, h is the Planck's constant, and E is the magnitude of electron's charge. According to the model, the magnetic moment of an electron in its lowest energy state will be. Okay, they're actually talking about the concept of Bohr magneton over here. Okay, so we know L is equal to 2. L is equal to kind of quantization of angular momentum, n times of h by 2 pi, nh by 2 pi, nh by 2 pi. Also, we know that the magnetic moment which is there, it is given by q by m into angular momentum, or I can say the magnetic moment is equal to q by m into nh by 2 pi, nh by 2 pi. Okay, the magnetic moment of an electron q is equal to electron at its lowest orbit means n is equal to 1. From here I would be getting m is equal to eh by 2 pi m, eh by 2 pi m. This is the answer. Three identical heat conducting rods are connected in series as shown in the figure. The rods of the sides have thermal conductivity 2K, while that in the middle has a thermal conductivity K. The left end of the combination is maintained at a temperature 3T and the right end at T. The rods are thermally insulated from outside. In steady state, temperature at the left junction is T1 and the right junction is T2. What is the ratio of T1 by T2? All these three conductors are connected in series. So in series combination, the heat current, the flow of heat current will remain same. The flow of heat current is going to remain same. When I'm saying the flow of heat current is same, I can say H is equal to K thermal conductivity into area of cross section divided by length into temperature difference, right? For the first conductor, 2K into A divided by L. What is the temperature difference here? 3T minus T1. This will be equal to K A by L into T1 minus T2. And this will also be equal to 2K A by L into T2 minus T. T2 minus T. Now what you have to do? Compare these two, equate these two. On equating these two, what you are going to get? On equating the first two equations over here. Okay, let me just take the last two equations. Take these two equations. 2Ka by L, it's same. So I can say 3T minus T1 is equal to T2 minus T. Or I can say T1 plus T2 is equal to 4T. Is equal to 4T. Okay. Also now consider the first two equations here. From here I can say 2 into 3T minus T1 is equal to T1 minus T2. Or I can say 6T minus 2T1. 6T minus 2T1 is equal to T1 minus T2. Or from here, I can also write 6T is equal to 3T1 minus T2. 3T1 minus T2. Let me put this as equation 1 and 2 respectively. Okay. Now by equating both the equations, okay, what you can do, you can directly add when you're adding 1 plus 2. When you're doing 1 plus 2, what you're going to get? You're going to get 10T is equal to 4T1. So from here I get T1 is equal to 10 by 4T, which is also equal to 5 by 2T. Similarly, T2 can be written as 4T minus T1. This is equal to 4T minus 5 by 2T. This is equal to 8 minus 5 whole T by 2. So T2 is equal to 3 by 2T. Now take the ratio. T1 by T2 will be equal to 5 divided by 3. 5 divided by 3 is the third option which we are having over here. That is the answer. The plates of a parallel plate capacitor are separated by D. Two slabs of different dielectric constants K1 and K2 with thickness 3 by 8T and D by 2 respectively are inserted in the capacitor. Due to this, the capacitance becomes two times larger than when there is nothing between the plates. Okay. If K1 is equal to 1.25 K2, what is the value of K1 is the question. Okay. Let K1 is equal to K. Okay. So K2 will be equal to K1 by 1.25, or I can say K2 can be written as 4 by 5 K. Now a capacitor, parallel plate capacitors are there. Between them two dielectrics are kept. Okay, K1, K2, thickness T1 and T2. If this is the case, the capacitance is given by A epsilon naught divided by D minus T1 plus T2 plus T1 by K1 plus T2 by K2. Now, what is the value of T1? T1 is equal to 3 by 8 D. T2 is given as D by 2. In terms of 8, if it is there in the denominator, that will be convenient. So T2, let me take it as T2 is equal to D by 2. Let me put it as 4D by 8. It will be easier for my simplification. Put all those values over there. From here you get C is equal to T1 plus T2 will be equal to 7D by 8 plus 7D by 8 plus 3D by 8K plus 4D by 8 into 4 by 5K. So from here I can write C is equal to A epsilon naught whole divided by D by 8 plus 8D by 8K. Okay, 8D by 8K. From here I can write C is equal to A epsilon naught whole divided by D. If you take commonly outside, you will be left with 1 by 8 plus 1 by K. According to the question, this value is equal to 2 times of the air capacitor value. Okay, so A epsilon naught by D, A epsilon naught by D goes off. This will give you 1 divided by 1 by 8 plus 1 by K is equal to 1 by is equal to 2. From here I can write 1 by 8 plus 1 by K is equal to 1 by 2. All you have to do is find the value of K right now. Okay, by doing this I can get 1 by K is equal to 3 by 8, or K is equal to 8 by 3. 8 by 3 means what is the answer? Nearly equal to 2.66. Question number 21. Two cities X and Y are connected by a regular bus service with a bus leaving in either direction every T minutes. The girl in scooty is driving with the speed to 60 km per hour in the direction X to Y. Notices that a bus goes past her every 30 minutes in the direction of her motion and every 10 minutes in the opposite direction. Choose the correct option for time period for the period T, the bus service, and the speed of the bus. Okay, let me say this is the station X and this is the station Y. From here to here, same distance, no? Distance is going to be same. Let me say the velocity of the bus is VB and velocity of the girl in the scooty is VS. Okay, VS. Now see what is happening. So first thing what you have to notice is when the girl, she is going, the scooty speed, it is given as 60 km per hour. Okay, 60 km per hour. Okay, so she goes a bus passing her every 30 minutes in the direction of the motion. Okay, along the direction of the motion, along same direction when they are going, when bus and the scooty is going in same direction, let me say the time taken T1 is equal to 30 minutes. Since everything is in kilometer per hour, let me call it as 1 by 2 hour. Okay, when they are going in the opposite direction, time t2 is equal to 10 minutes. This is nothing but 1 by 6 hour. Both are traveling the same distance, right? Same direction. Okay, in case of same direction, the distance which has been mentioned will be equal to. Now apply the concept of relative velocity. When both the vehicles are going in the same direction, the relative velocity is taken by the difference of the velocity. So let me put it as VB minus VS into T1. Similarly here, S will be equal to VB. Since both are moving in the opposite direction, minus of minus will become plus into T2. Both are having same distance, means we can equate both of them. VB minus VS into 1 by 2 is equal to VB plus VS into 1 by 6. Okay. From here, 3VB minus 3VS is equal to VB plus VS. Or I can say 2VB is equal to 4VS, or VB is equal to 2 times of VS. 2 times of Vs is equal to 2 into 60. This is equal to 120 kilometer per hour. Okay, 120 kilometer per hour. Okay, now how will you find the time interval? Time interval between each bus is equal to 30 minutes, right? 30 divided by 120. This will be equal to 1 by 4 hour. 1 by 4 hour means it is equal to 15 minutes. A uniform rod of mass 20 kg and length 5 meter leans against a small vertical wall, making an angle 60° with it. The other end rests on the rough horizontal floor. The friction force that the floor exerts on the rod is. Okay. The friction force that the floor exerts on the rod is equal to. This is the question. Okay. So what you will be doing in this particular case? Draw the diagram first. Okay. Let me call this as 60°. It is making 60°. Okay. Now when it is making 60°, what will be there? You will be having one normal component. Okay. One normal component here. Another one normal component here you will be having. And this length they have given it as 5 meter. If this length is 5 meter, what would be this length? This length will be given by this is 5 cos 60. So 5 by 2 meter. Here 5 root 3 by 2 meter it will become. Okay. So the body is resting. Okay. It's resting on the rough horizontal floor. The friction force that the floor exerts on the rod is going to be. What we can do is we can apply the torque method over here. Okay. We can apply the torque method over here. From the center of the mass, mg downward. From the center of the mass, mg downward. Okay. And then you would be having the component due to the friction over here. The component due to the friction over here. And also you will be having due to N2. So torque has to be equated to 0. The torque has to be equated to 0. From here, I can write f of 5 by 2, f of 5 by 2 minus n2 of n2 of 5 root 3 by 2 plus mg of. Okay, now what you have to do, this entire length is 5 by 2 root 3, right? Mg from the center of point, what distance is that? Only that has to be considered. So 5 by half of it, right? 5 by 4 root 3, this will be equated to 0. And here from the diagram, okay, you might be seeing it here, okay. So we can say the normal reaction which is given over here, okay, the normal reaction which is given over here, okay, the component over here f into 5 by 2 minus mg into 5 root 3 by 2 plus mg into 5 by 4 root 3 is equal to 0. Here you will be getting, if you take the 5 by 2 component outside, 5 by 2 f minus root 3 mg plus root 3 by 2 mg can be equated to 0. Okay. So from here, I can say f is equal to root 3 by 2 mg. Okay. Root 3 by 2 mg. Substitute the value of m and g, you will be getting 100 root 3 Newton. 100 root 3 Newton. In an oscillating spring mass system, a spring is connected to a box filled with sand. As the box oscillates, sand leaks slowly out of the box vertically so that the average frequency and average amplitude of the system changes with time. With which of the following options schematically depicts these changes correctly? So first we'll talk about the angular frequency or the average frequency over here, which is obtained by the formula k by m root over. Now, when the sand particles are slowly leaking out, what is happening? The mass value is decreasing, and hence what will happen? The frequency value will increase. So, omega is inversely proportional to root over of m. Okay. So, for this, the graph value would be somewhat like this. Now, again, what is happening? The amplitude value, since see, energy is equal to half Ka square. Since the mass value is slowly decreasing, some amount of energy loss also occurs. Okay. So energy loss, when it is occurring, what happens? The amplitude also decreases. Energy loss indicates decrement in the amplitude. So these two details are perfectly satisfied by the graphs shown in the option 2. A balloon is made up of material of surface tension S and its inflation outlet from where gas is filled in it has small area A. It is filled with a gas density rho and takes a spherical shape of radius r. When the gas is allowed to flow freely out of it, its radius r changes from r to 0 in time t. If speed v of gas coming out of the balloon depends on r as r to the power a. Okay, and t is proportional to s alpha a to the power beta rho gamma and rho delta. What is the value of alpha, beta, gamma, delta is the question. Okay. So here what they have told here they have mentioned that the speed is depending. Okay, the speed is depending. The value of speed which is there, the speed is proportional to surface tension to the power alpha, okay, area to the power beta. Okay, density to the power gamma, and the value of r which is there, r to the power delta. I can say L T inverse is equal to m t to the power minus 2 alpha L square beta, density m L to the power minus 3 gamma, and L delta. From here, you will be obtaining m alpha plus gamma L 2 beta minus 3 alpha plus minus 3 gamma plus delta t to the power minus 2 alpha minus 3 gamma. Compare the conditions. Alpha plus gamma is equal to 0. 2 beta minus 3 gamma is equal to 1. And minus 2 alpha minus 3 gamma will be equal to minus 1. Okay. Alpha plus gamma is equal to 0. Alpha plus gamma is equal to 0. Which is it getting satisfied in any of the condition? Alpha 1 by 2, gamma 1. No. Minus 1 and minus 1. No. Minus 1 and plus 1. Here 1 by 2 and 1 by 2. So this condition is satisfied by option 3 only. So to save some amount of time, you can have this approach. Or else conventionally, you can substitute and also get the answers. Consider the diameter of a spherical object being measured with the help of vernier caliper. Suppose its vernier scale division are 10, coinciding with 9 main scale divisions. Least count is 0.1 centimeter. Okay, and the 0 of the vernier scale is at x is equal to 0.1 centimeter when the jaws of the vernier calipers are closed. That is indicating about the 0 error. Main scale reading for the diameter is 5 centimeter and the number of coinciding division is 8. What is the measurement of diameter? Okay, final reading is equal to MSR plus VSR into least count. So from here I can say final reading is equal to MSR plus VSR into least count. MSR value is 5 plus VSR value is 8 into 0.1, 5.8 centimeter. But this is not the answer. 0 error is there, so you have to do the 0 correction. Okay, actual value, the actual value which is there, this is equal to 5.8 5 point this is given in the centimeter. Okay, so the least count value which is there, what is the least count value? With the help of vernier caliper, suppose 10 VSD is coinciding with 9 MSD. Okay, the least division in the main scale is 0.01 centimeter, right? So here least count, the value of least count which is there, least count is equal to 1 by n into MSD. So this will be equal to 1 by 10 into 0.1. This is equal to 0.01 centimeter. So here it should be 0.01 centimeter. So 5.08 centimeter. Okay. The actual value will be 5.08 minus 0.1. Since 0.1 is the 0 error over here. This will give you 4.98 centimeter to be the actual answer. 4.98 to be the final answer. The next question. A parallel plate capacitor made of circular plate is being charged such that the surface charge density on its plate is increasing at a constant rate with time. The magnetic field arising due to the displacement current is okay. So this is the question. This is the question. Okay. So see here the displacement current, when they're talking about displacement current, ID is going to be equal to epsilon naught d phi by dt. So from here I get epsilon naught d by dt of electric field into area. Okay, electric field into area, or I can say epsilon naught A into dE by dt. Or this can be also written as epsilon naught A into d by dt of sigma by epsilon naught, or I can say it is equal to A d sigma by dt. So area is not going to change. And also what they have told, the charge density on its plate is increasing at the constant rate, indicates that d sigma by dt is also a constant value. So my displacement current is going to be constant. The displacement current is going to be constant. Okay, it can't be zero. First of all, it can't be zero. Okay, it won't be zero at all. So how it is going to behave when it is not zero? The wire which is there, it behaves like a cylindrical surface, and the magnetic field will be with respect to that particular distance, RB. Application of Ampere circuit law, which we have seen, the magnetic field variation will be something like this, right? It will be non-zero everywhere with maximum at the imaginary cylindrical surface connecting the peripheries of the plates. Option 3 is the correct answer for this question.